Fractions. Okay, we're looking at how to add, subtract, multiply, and divide fractions. I know they can be a little bit of a stumbling block for some people, but they're actually not that bad. Once you learn a handful of rules or properties, then hopefully you'll learn to love them and you'll see why fractions are actually your friend. So first, let's take a look at some vocabulary, some terminology. We have here a fraction, right? And there's two important parts to the fraction here. There is something on top and there's going to be something on the bottom, okay? And these have special names. So usually the part that's on the top, we call that either the numerator or the dividend. And the part on the bottom, we call that either the denominator or the divisor. Okay, so these are the two parts of a fraction, and that's because fractions sort of indicate division, right? And so that's where these division type vocabulary words come into play. So we can call this, of course, a fraction, but there's a few other ways we can call this. We can call it a quotient or even a ratio, right? So these are all different words that essentially mean the same thing, this kind of fraction. Now, why did I have a little orange Q here? Well, that's because this was the symbol we used for rational numbers. And if you remember, a rational number is a ratio of integers. It's any number that can be expressed as a ratio of integers. Okay, so we talked about that before when we looked at different types of numbers. So rational numbers come from the word ratio, but we use the symbol Q to represent them from the word quotient, and they're actually also can be expressed as fractions, right? Okay, so let's take a look at essentially the first important rule or property of fractions that we need to know. All right, here we are, the very first rule, and this one is actually fairly straightforward. Let me use an example here. What if I have 4 divided by 6? Well, the idea is this rule tells you how to simplify a fraction. This 4 times 6, I can decompose each of these terms, the numerator and the denominator, into its factors, right? So 4 is the same as 2 times 2, and 6 is the same as 2 times 3. And so what this is saying is, this rule number 1 is saying that I can now actually sort of cancel out these two 2's. They're going to cancel out because, of course, 2 divided by 2 is 1, right? So this is basically the same as saying 1 times 2 over 3, and that's just the same as 2/3, right? So we don't even need to write that anymore. We can literally just write this as 2/3. So we can simplify a fraction by finding common factors and canceling them out. Okay, so that's what this very first rule is showing you. We cancel out these c's, we're left with a over b. Let me try and demonstrate this a little bit graphically. Okay, so what if I have a little pie. Okay, I've got a little circle, I've cut it up into pie pieces, and I've cut it up into 6 equal pieces. Okay, so this is basically each of these pieces is 1/6 of the whole entire object. Well, what this fraction is saying is that I have 4 of these 6ths. So I can represent that by sort of coloring in 1, 2, 3, 4. Okay, there we go. So that's 4 out of the 6 pieces. That's 4/6 of one whole. And this rule number 1 is saying this 4/6, well, that's the same as 2/3. And if you look at this, this does look like I filled in 2/3 of this pie, right? So let me give you another pie here. And here, this one is split up into thirds. And so if I was to essentially color in 2 of these thirds, then we should see that these are going to be equivalent, right? So 4/6 of a pie is the same as 2/3 of a pie. They are equivalent. All right, so that is our first important rule. Let's look at the next one. All right, property number 2 here is all about multiplying fractions, and it turns out multiplying fractions is very easy. If you know how to multiply two numbers, you know how to multiply two fractions. Let me show you. So let's say we have 3 over 2, and we want to multiply this by 3 over 4. What you can do is you can sort of connect this line across and imagine these are already sharing parts of the same fraction. You just take the top part, multiply it together, take the bottom part, multiply it together, you get your answer. So what I'm saying is this will equal 3 times 3 over 2 times 4, and that's going to be, well, 9 over 8, isn't it? Okay, so there we go. Very simple idea here. Let me show you maybe another way to think about this. So I'm going to take this, this 3 halves here, and I'm going to decompose that. I'm going to think of 3 halves as actually 3 times 1 half, right? So 3 times 1 half, that'll get us 3 halves. And then this 3/4, well, I'll think of that as 3 times 1/4, right? So that's another way we could think about this problem. And because multiplication is commutative, I can take these numbers, these terms, and I can rearrange them. And I'm going to make this into sort of 3 times 3 times 1 half times 1/4. And now I can do this multiplication. So 3 times 3 is going to be 9. And 1 half times 1/4, what's that going to be? Well, that should be 8, okay? But how do we know that's 8? Can we think about that? Yeah, let's think about this graphically, okay? So let's say I have a pie again, and I'm going to cut this up into 4 pieces, okay? So this is going to represent this here. And what I want to do is I want to take one slice, 1/4 of this pie, and what I'm saying here is I want to take 1 half times that 1/4. So 1 half of 1/4. So I'm going to multiply this, or sort of divide it by 1 half. Let me do that in white. Okay, so 1 half times essentially this quarter. What's that going to be? Well, I'm going to have to take that quarter and cut it in half. What do I get then? Well, I should get something like say this is going to equal, cut it into quarters, I'm going to cut this into half, right? And so what I'm going to wind up with is just this one little slice here. And if we look at that slice, how big is that? Well, that's 1/8 of the entire pie. So we can imagine that 1 half of 1/4 is actually an eighth. Okay, and so that's where we can get that from. We can imagine this graphically, or we can just use this rule number 2 here and see how we can multiply the numerators and then multiply the denominators, and then we get our answer. So not too bad. Let's take a look at property number 3. Property 3 is about division. It's about how to divide fractions. Now, this can be a little bit more tricky than multiplication until we remember that division is actually multiplication in disguise. We say that division is actually the multiplication of a reciprocal. Okay, so let's try and review what I mean here. Let's say I have 2 divided by 3. Okay, I can think of this as division, or I can think of this as 2 multiplied by the reciprocal of 3. Then I am taking division and transforming it into multiplication. And so then this becomes 2 over 3, right? There we go. So division is actually multiplication in disguise. And so once you're able to translate it into multiplication, then we're just multiplying fractions, and we already learned how to do that. So let's try an example here of dividing some fractions. How about we have our 2/3, and we're going to divide that by, how about 5/7? Okay, so we want to transform division into multiplication of a reciprocal. So we're going to have now 2/3 multiplied by the reciprocal of 5/7. You have to flip that fraction over, right? So we're going to get 7/5. And now it's just multiplication. We know how to do this. This is going to equal 2 times 7 on the top and 3 times 5 in the denominator. So we're just going to get 14 15ths. There we go. Perfect. We know how to divide fractions. Let's look at the fourth property. Property 4 is about adding fractions. In particular, it's about adding fractions that share a common denominator. Okay, so both of these fractions have a common or the same denominator. Let's look at an example. Okay, let's say we have 5/3 and we want to add 2/3. What are we going to get? Well, this rule is telling us we just add the numerator together and we keep the same common denominator. So this will wind up being 7/3. Okay, that's how we can do this kind of addition. Let's see if we can try and understand this graphically, right? So let me get a little pie here. Here's the little pie. Let me copy that and let me copy that one more time. Okay, so here's the idea. I'm going to add these together. I want these two pieces. I'm going to have here 5/3, and here I'm going to have a 1/3. Okay, and I want to add, oh, sorry, I want 2/3, don't I? I'm going to have 2/3, and I'm going to add them together. Okay, so let me color this in. So this is going to be 5/3. Well, this is 1/3, 2/3, 3/3, 4/3, 5/3. Okay, so there's 5/3, and I'm going to add 1, 2. I'm going to add 2/3. What am I going to get? Well, if I add them together, I can count. I get 1, 2, 3, 4, 5, 6, 7. I get literally 7/3 as expected. So we can literally just think about chunks of a pie and counting them up, and that's why the denominator doesn't change, right? We're still dealing with the same unit size, 1/3 in this case. You could be adding quarters or fifths or tenths, but that's going to be the size of the chunk, and then you're just counting up how many you have. You just add them together, add together the numerator. So this is how we can add fractions that share a common denominator. In fact, this is what we do when we add like integers. So for example, if I was going to be adding the numbers 3 plus 7, well, this is going to be 10, right? But we can think of these as fractions. We can think of the number 3 as actually 3 over 1, 7 is 7 over 1, and 10 is 10 over 1. And so now we're adding fractions. But look, it all works, right? Because they have a common denominator, in this case, 1. Okay, so that's one way we can look at this. It turns out this rule is exactly the same rule as we use for subtraction. So addition and subtraction are going to be the same because actually we said subtraction doesn't exist, right? Remember when we looked at subtraction. So let me look at an example here. What if we have 5/3 and we want to subtract 2/3. Okay, so we want to think of this not as subtraction, but as addition. We're going to transform this into addition. We're going to say this is 5/3 plus negative 2/3, right? So we think of subtraction as the addition of a negative number. And now it's just addition, and so this is just going to be then 5 plus negative 2 over 3, which is going to be same as 5 minus 2, which is just 3 over 3. And using our first property, we know we can sort of cancel out these 3's because 3 over 3 is the same as just 1. Okay, and so this fraction operation, this subtraction, winds up equaling 1. Okay, let's take a look at property number 5 here. Rule 5 here is also about addition, but it's about addition of fractions that do not have a common denominator. The denominators are different, okay? So they do not have a common denominator, and that makes this rule the most difficult one out of all of them. So let's sort of take a look at how we do this. Let me look at it graphically first. So I want to add together 1/2 plus 1/3. So let me get a pie. Okay, so this is going to represent, here's 1/2. Okay, so this is going to be my 1/2. And I want to add this to 1/3. Okay, so I'm going to get another pie here. And this is going to be my 1/3. Okay, let me color this one in. So there's my 1/3 of that pie. And what is this going to equal? Well, I'm saying that this should equal sort of the combination of these two. So if you look at this and you try and combine this chunk with that chunk, you should get something that looks sort of like this, right? So I'm going to color this in. I'm going to get that 1/2 plus my 1/3, and I fill that in, and I want to see how much of the pie do I have now. Well, if I look at this missing piece, right, this missing piece over here, that kind of looks like half of this third. Half of a third, this is going to be a sixth. So I'm missing 1/6. That means I actually have 5/6. Okay, so I expect to get 5/6 when I add 1/2 plus 1/3. But of course, if you expect to go through all of Precalculus by drawing little pictures of pies and slices and adding them up, well, that's not a great long-term strategy, okay? We want to actually be able to do the arithmetic with the numbers and the symbols. So let's see if we can do that. I'm going to add now 1/2 plus 1/3, and I want to see what I'm going to get. The problem is, these are not the same denominator. It's not a common denominator. So the strategy with rule 5 here is to change the fraction and transform both of these fractions so that they do share a common denominator. And in this case, the way I'm going to do that is I'm going to multiply 1/2 by 3/3, and I'm going to multiply 1/3 by 2/2. Okay, why do I do that? Let's see what we get. So for this first one, when I do that multiplication, I'm going to get 1 times 3 on the numerator, and then on the bottom it's 2 times 3, well that's 6. For the second one, I'm going to get 1 times 2, well that's 2, and then 3 times 2, well that's also 6. So look what's happened. I have now created a new addition problem with two fractions that share a common denominator. And I know how to add these. I just add the numerators. So this is 3 plus 2/6. That is 5/6 as expected. Okay, so this is sort of the key point. You want to find a way to transform your original fractions so that they do have a common denominator. And the easiest way to do that is just sort of multiply them together, right? B and D, you're going to multiply B times D. You're guaranteed to get a common denominator if you do that. Let's look at a slightly more difficult example here. What if we have 7/10 plus 5/21, and we're going to add these two fractions? Of course, they do not share a common denominator, so we must transform them into some other fraction so that those two fractions do share a common denominator. And the way we're going to do that is we're going to multiply 10 times 21. That gives us 210. So 210 is guaranteed to be a good number to use here so that we can transform both of these fractions into something that share a common denominator. So how do we do that? Well, we're going to have to multiply the first one. Well, we want 210 on the bottom. We have to multiply then by 21, and then we have to be 21/21 so that this entire thing is actually just 1, and 1 times anything is the same thing, right? And so same thing here, we're going to multiply this now by 10, and so we need a 10 on top. Okay, so that's the key point. Now we just do the addition. Okay, so well, we have to transform this. So 21 times 7, that's going to be a 147/210. And 5 times 10, well, that's 50/210. Now we can add them together because they share a common denominator. We're going to get 197/210. And now we're done, okay? So we're able to take these two fractions that do not share a common denominator, but then transform them so that they do, and then we can just add them together very easily. All right, so that is rule number 5. Let's look at the 6th and last one. This last property is a little bit different than the other ones because it's not an operation. We're not adding or multiplying fractions. Instead, we have an equation where two fractions are equal to each other, but there's a way to rearrange the equation and write it in this form. And that's going to make it usually a lot easier to solve algebraic expressions. This whole thing is actually called cross multiplication, and we'll see why in just a second. So let me look at an example. What if we have 2 over 3, and we say that is equal to 4 over x? We want to solve for x. We want to find what is x equal to. One way we could do this, not using this property exactly, what we could do is multiply both sides by 3x. Okay, so if I multiply both sides of this equation by 3x, then the equality holds, right? So there's still left and right side is still equal. And look what's going to happen. This 3 is going to cancel here, and this x is going to cancel here. So that what we're left with is, well, on the left-hand side, it's going to be 2 times x is equal to, on the right-hand side, it's going to be 3 times 4. Well, that's 12. And so I've rearranged it, and now it's easy to solve for x. I can just divide both sides by 2. That's going to cancel out. And so we can see that now I'm just going to have x is equal to 6. Okay, so I've solved it. This sixth property is basically a shortcut way of doing what I just did. What we can do is we can say this, we have this 2 over 3 is equal to 4 over x. And what we're going to do is we are going to cross multiply like this. So we're going to take this denominator here, this 3, and we're going to multiply it with the numerator here. We're going to take this x and we're going to cross it over and multiply it by that numerator over there. And that is how we get 2x is equal to 3 times 4, which is 12. Okay, I'll just write it as 3 times 4. So we've cross multiplied just like that. It's a shortcut way of doing this. Okay, it's actually the exact same thing. It's just a shortcut. So cross multiplication is going to be our friend. And from here, of course, we can solve for x very easily. In fact, you can also cross multiply the other way. So if I wanted to, I could have taken this 2 and crossed it down across the equal sign into the denominator. And if I do it that way, look what happens. So let's say I take the x and I cross it on the top. So I'm going to get an x on top. And then the 3 I'm going to cross over here. So I have 4 times 3, and then the 2 I'm going to take and put it in the denominator, and so that's going to give me a 2 on the bottom, right? That is going to be 12 over 2. That is going to be 6, and so I can sort of do a double cross if you want to look at it that way, right? This goes up here and this goes down here because I'm just solving for x. So that's the same idea here. Cross multiplication of fractions, really, really useful technique for solving algebraic expression. All right, hopefully this was a good overview of these 6 important properties of fractions that allow us to very easily add them, subtract them, multiply, divide them, and manipulate them so we can solve algebraic expressions. With a little bit of practice, they'll become second nature and fractions will be your friend.